This video is on the table of Laplace transforms, but also how to use WolframAlpha to actually compute these so you can check your work. Right, you do need to do these by hand. You can't just use WolframAlpha on the test, and you won't learn it unless you do it. But let's go ahead and begin. So the first, you can use WolframAlpha to do Laplace transforms, and the example here, so this is actually what you need to copy into the WolframAlpha prompt. So it's Laplace transform. It uses these square brackets as the arguments. This is the function that you're going to take the Laplace transform of, so square root of t, and then the argument like pre-Laplace transform is t, and the variable after the Laplace transform is s. And then for legal reasons, I'm not going to take a screenshot of WolframAlpha, but so part of the output, apparently the Laplace transform of square root of t is the square root of pi over 2 times s to the 3 halves. Right, so that's not something maybe that you would see in every table, but WolframAlpha can do some of these for you, and you can check your work. Right, there's also a link right here if you just want to click it so you don't have to type this in yourself. Right, so that's one. Then there's some other ones. So we also have example 2 here. It's Heaviside, and so WolframAlpha uses Heaviside theta for the Heaviside function. And so it's Heaviside theta, its input argument is t minus 4, and it's multiplying an exponential e to the positive 3t. And right, it's Laplace transform, the input variable that's being used is t, and then the output is going to be s. And so it does the kind of trick to change this function for you. You'll see in the lookup table. So you end up with e to the 12 minus 4s times s minus 3, right? You kind of have to do this weird thing where you have to formulate this function as if it has an input argument of t minus 4, something like that. Right, so that's always a little tricky to do, but you could at least check your work using this. Alright, so that's one way to put in Heaviside theta. You probably know how to put in pretty much every single function. The only other one that is a little unique is the Laplace transform for the Dirac delta function. So to use that, WolframAlpha calls the Dirac delta function Dirac delta. So it's t minus 2, and then here I have times e to the negative 3t. And so the part of the output, the answer to this, is e to the negative 2 times s plus 3. Alright, so if you were trying to do this yourself and you wanted to check your work, you could use that. And again, there's a link in the header here to take you there with this input. Or you can just copy it and paste it.